welcome. I'm excited that everybody is here. I'm excited to be here, and I'm excited that AltaSea is here. This place is unique. It's the only place I know like it in the world, and we have been looking. Okay, so I'm going to start off with the big picture, and then we'll talk later about RCAM and about how we fit into the big picture and how AltaSea fits into the big picture. So this is the well-recognized moonrise photograph taken on Christmas Eve in 1968 from the Apollo. And it just helps us appreciate what a precious jewel we have. It helps set the perspective. And then what probably a lot of us know, but we often forget, is that the atmosphere, that blue layer, is a relatively thin layer, even though you look up today and it's a beautiful day and the sky is so far away. Okay, now, I'm not going to belabor this point. This presentation is going to be inspirational, offer hope, but it's important to understand the urgency of what we're facing. So these are greenhouse gases. The largest source is from burning of fossil fuels, which comes primarily from automobiles and electricity generation. All of things that can be basically electrified using different sources. This is not new to people. This is what it means. This is from California. Unfortunately, I fear that for some of you, it's too close to home. Not going to belabor this. Of course, we know about droughts. Also California. And there's this thing called rain bombs. You know, in preparation for this speech, I watched Al Gore's Truth to Power, the sequel to, the name is escaping me, but what's interesting here, what caught my attention is that he said every storm is different now, right? And that's quite interesting because it's warmer. So things are changing, and that's the last kind of scary slide. Oh, I forgot. Of course, you have to mention the ocean. The ocean is warming too. All right, let's get past that. So there's hope. For example, in wind energy, there's so much potential wind energy onshore and offshore that you can provide all the electricity the world needs 40 times over. Now, you have to get there to do that. And then there's solar. You've probably been hearing a lot about solar. You've probably been seeing more and more solar. This is what's been happening in terms of solar deployments. And if you look here, starting around 2010, they've been shooting through the roofs. Now these slides, this is 2019. This curve has gotten steeper. Things are moving even faster. So things are happening in the positive direction, faster and faster all the time. Why is that happening? Well, since the 80s, research scientists have been trying to get the cost of solar down, come up with new methods, and finally, down in 2020, you can see how much progress we've made on solar energy. And it's continuing. That's one of the things we're doing today. So I like this one because it shows what Chile did. Starting in 2013, this is how much solar they deployed in different years. And this last one, I think, is 2019. So that's how quickly, it gives you a perspective of how quickly these things can be done. So yeah, so the small one there, I can barely read the text, but I think the small one is 2013, and the last one looks like 2019. And California is also very much leading the way. That's why we are here today. You may be aware that in 2045, California has set a 100% renewable energy goal. I can tell you that is absolutely possible. I can tell you that is happening. Okay, so a little bit of a pop quiz. This is an easy one. So who thinks, let me just ask, does somebody know what the cheapest form of electricity is that you can buy today? Just throw it out there. Hydro, new forms of electricity. If you're going to install new electricity, it's not hydro, it's not wind, it is solar energy. So solar energy today, this is a California plant. This is Apple's plant. Solar energy costs about 1/5 the cost of coal, 1/4 the cost of nuclear. 1/3, actually it's about half the cost of natural gas generated electricity. So solar is cheap, but it does take up a lot of land, and a lot of people don't want to look at this, understandably. And it does have environmental impacts as well. So that means solar's great, but we need additional options as well. So that's where, and you're going to be hearing more and more about this if you haven't already, that's where floating wind comes into play. Now keep in mind, California has over 800 miles of coastline. You look out, and it's hard to even comprehend how much water is out there. There's also one of the best wind resources out there in places you can't even see. So what's happening in California is that it has set a 25 gigawatt goal, and I think there's two numbers there. One is 5 gigawatts by 2030. So this is happening in less than 8 years, about 7 years, and a 25 gigawatt goal by 2045. Well, what does that mean? Every gigawatt is about 1 million houses. So 5 million houses will be receiving effectively offshore wind power by 2030 and 25 million by 2045. And this is going to be one of the biggest markets in the world, and it's starting to happen. And what you will hear is next month, this is all happening in federal waters, but next month they'll be auctioning off 2 sites. You can kind of see it there on the left. One is in Northern California and Humboldt. The second one is off of Morro Bay. Let me do this. So it's this little pork chop sized piece there, and this one off Morro Bay, and then of course, if you're not from California, we're down here. So they'll be auctioning that off, and on those sites you can put about 5 gigawatts of offshore wind. It's going to bring jobs, it's going to bring clean electricity, and because it's at least 5 miles offshore, thereabout, you'll hardly be able to see them. And that's important for reducing public concerns. So this is new. This is starting to happen. The U.S. is one of the fastest places that this is starting to grow. So that is floating solar, right? So why would you do floating solar if we've already got such cheap solar? There's a couple answers for that. The main one is it gives you options. We need all of the above. We need all of these clean energy sources. And so what you do here is you actually float these solar panels, as you can see, and then you need anchors to keep it from floating away. But it provides options that you can put solar that you wouldn't. For example, a city municipality who has water area, like a water treatment plant, can put floating solar there, but they may not have the land. Equally important is the ability to combine it with hydropower. So this is a new thing that's happening. And an even newer thing is you can put this in the ocean. This is happening. This is China. You know, I failed to mention that everything I've shown here is not just happening here in California, here in the US, here in Canada, Mexico, Australia, Europe, all of the countries. There's thousands of people working together to advance these technologies. And that's why there's hope and inspiration. So this is starting to happen. They're calling them hybrid power plants, where you're combining floating solar and offshore wind, because we know that solar power does not generate electricity overnight, so that's when the wind turbine kicks in. You can store a certain amount of energy in batteries and other methods, but so you'll hopefully be hearing more of that, and that's an area that we're starting to work in. Of course, there's challenges. We do make mistakes. We try and move quickly in floating solar, and this is where we're starting to work into what is RCAM? What are we doing in this, and who are we anyway? So this is what can happen. I think this one might be in China. Sometimes we do things a little more slowly here. But what role do we play in that? So we're a very small company. We're a startup. We're only 4 people. You know, how can we affect this? Now we're growing, but we've got our office here. We've got offices in California, in Boulder, Colorado, and then we have a virtual office in Scotland, which is another one of the incredibly most windy places on Earth, offshore. So we've got, myself, I worked for 20 years at National Renewable Energy Laboratory before leaving to start this company. And then we've got Gabe, Taylor, and Mason, all of whom are civil engineers, and they're in the back. And then I want to make sure that you stop by to see our robot and our 3D printing after this. I think they're mixing the concrete right now, so you can see that real time. But what is it that we can do as such a small company? And this is a little bit... Okay, so why did we start? How did we get started? Well, I started in Colorado. I was studying, how do we get these bigger wind turbines? The towers are so big, you can't even get them over the road. How do you do that? And I was fortunate to be able to tour a facility where there was a 3D printer at Oak Ridge National Lab that was about maybe the size of this audience and about, 8 feet tall. And I was working on that problem at the same time. Now, they were printing plastic, but we said, well, we can do that on site. Right? We can print those towers on site with this printer here. And so in 2016, this is my first sketch in 2016 of, this is how we can do it. We called it the pottery wheel concept, where you have a tower section and you have a robot. I hadn't even envisioned a robotic arm that we just bought from ABB. But so it was a pottery concept. And thought, well, you can build this huge base and you could do some interesting things with the foundations. And I took my inspiration from the tree roots of a sequoia. It's probably from Sequoia National Park. And there's some sketches there. I was very excited. Walked into the conference room, presented it to my senior managers, all of whom had 10 or 20 or 30 years more experience than I did. And they're all male. There was one female in the room. It was the administrative assistant who had set it up. And I pitched the idea, and basically what ended up happening, there's one person that liked it, everybody else shot it down, and they told me you should spend your time on something else, that it's just not going to work. The one person who liked it was the female in the room who didn't have those preconceived ideas. And that was my first lesson in diversity, that it was the young, she had, you may call it less formal education than everybody else in the room, but she said, I think you had the best presentation and you have the best idea. So I had to leave the National Renewable Energy Laboratory to pursue this idea, and that's why I started RCAM. So, now, at the time, that was 2016, and this is one of my concepts. I didn't know at the time that Dr. Barak Koshnevitz from the University of Southern California had actually invented, and there was some prior IP on the idea. I learned that later. But this is really important here, because we got the first ever public funding in the world from the California Energy Commission, right? So I wouldn't be here today. I don't know what I would be doing after leaving NREL, but this is the first grant we got in 2018 to develop this technology. And everything else that I'm about to show you follows from that. So we partnered with UCI, and then just to show, for a long time, my biggest battle was convincing people I'm not crazy. And in 2020, GE, who's the powerhouse in wind energy, they started printing concrete towers. Now, that tower is the height of this building, and it's about the size of this audience around as well. So we're not crazy. Don't like having GE as a competitor. Got some stories there about employees that were poached, information lost. But so we started with this 3D concrete printing, and basically it's 3D printing technologies with concrete. We didn't have our own robots, so we went to Holland, to the Netherlands, where they're doing this, and they're actually, in some regards, ahead of us. It's kind of a classic story. But our mission is to use these technologies for renewable energy. We don't print houses. Everybody else prints houses. That's why we're different. The rest of the world is printing houses. we're printing renewable energy infrastructure. What does that infrastructure look like? Okay, so we started in towers, then we got some money from DOE to do, that's called a fixed bottom foundation. So all these things, anything that's gray in here is concrete, it can be printed. It actually has a lower carbon footprint than its steel competitors at all in. We're starting to move towards floating structures that can be printed here, literally in the Port of Los Angeles, and deployed at some of these locations. Why is that important? It means jobs. It means jobs for all the people who live around here. It means local materials. It means lower carbon footprint. That's really key to a lot of these ideas. Last year, we started to move into printing anchors for floating solar. We can do that on site at the installation site, or we can do it here, or we can do it at another port facility. We got funding from Scotland to explore anchors for floating wind turbines, and then we're continuing to pioneer new technologies. So there's about 6 or 7 ideas that we've explored. These are effectively water batteries because wind and solar have a lot of variability. I don't want to go into the technical details, but we're pioneering this stuff. All of it has been funded by the government. We haven't taken private investment yet. So we have this vision. We call it our 3D concrete printing renewable vision, where we can print all of this in probably a port location with multiple robotic printers running simultaneously. So here you see 6 printers printing various parts. And I can tell you this is coming. I mean, go look at what we're printing over there. Logos, solar anchors, those sorts of things. All of it with the same printer with 2 people. And we're working on further automating that process so that it can be 1 person. But you still need people in the company, and there's still going to be local jobs. Okay, so this is what you're looking for when you're looking for the demo. So that's our robot there. And then, of course, this is where AltaSea comes in. Almost all of those products were for the ocean, right? Maybe for the lakes, but ultimately they're for the ocean. There's so much land out there. In fact, we did a study. We looked at, if you had floating solar, if that technology gets developed for the ocean, you could have approximately a 10-mile diameter floating solar array off of Santa Monica that nobody could see because it basically disappears into the horizon. That would provide all the electricity that Los Angeles needs. It solves the problem of land space availability. Even if you put solar on all the roofs in Los Angeles, you're not going to have enough. So that is possible, but the technology does still need to be developed. But we can do it. So, because all of those things are ocean-based, our biggest challenge, we had two primary challenges in addition to convincing people that we weren't crazy. One was finding a place to print. It shouldn't be that hard, but we need 480 volts electricity, and our robot is 8 feet tall, and it doesn't fit in a garage. We considered putting it in my garage. It just didn't fit. So we went years, literally years, looking for a place to print. And then we found AltaSea, and that was a slam dunk, I can tell you. And the next challenge is, how do we find a place that will allow us to put these things in the water and test them? Well, AltaSea owns 70 feet out from the dock. So we have plans to take our anchors. We have plans, ideas at this point. These things are still early. To put a floating solar array outside that you can see, that we can test, that becomes an educational component as well as a research component. I don't think anybody, well, maybe they foresaw that when they were envisioning AltaSea, but I guess what I'm saying is it's working. There are programs in place that are actually working. I know it's easy to be cynical about the government and things, but for us, we would not be here if those systems were in place, and we are picking up speed, and we're growing. Okay, so here's one example. You can see up there, that's actually a big anchor. But basically, you can see these anchors. You're going to wonder what that fire pit is. It's actually an anchor for a floating solar system. It's a shell that we printed on site. And the idea is that we're reducing the amount of concrete that you use by half, we're reducing the cost by about half, and then you fill it with low-cost materials, whether it's sand, recycled concrete, aggregate rock, whatever it is that you have that's low cost. So you can see that down there, and that's what that funny-looking fire pit is. And again, that's for floating solar. And that shell, I want to point out, so that we had this done in Utah before we had our robot commission. This robot's only been running for maybe 6 weeks, if not less. But these shells that were printed, we had this done in Utah. Every shell was printed in about 15 minutes. Really fast, no form work. In fact, I think we asked them to print 2 or 3. I think the first time around they made some errors, so they just printed some more for us at no charge. So that's what's possible. And then I just got a couple more slides here. I want to show you what's next. So this is, you can find this on YouTube, but it's a virtual reality simulation of our next printer that we have money and that we're evaluating bids right now. So that printer, if you look at the fenced off area, look for the green, the fence with the green barrier around it. So that area was sized so we could install this printer. That printer will just barely fit in there. So it's, you have to convert from meters. It's probably 35 feet square. Again, it's about half this room, including the audience. 35 feet, and we're going to 35 feet, and we're going to go as high as we can, and that's about, I think we can get to about 20 feet tall. And we got New York to pay for that because they liked our research so much. They didn't like spending money for a $500,000 printer that would be put, in Los Angeles, but they liked what we were doing so much in the stores that they were willing to pay for that. So come back. It's probably going to be at least 6 months before that's delivered. We'll have another ribbon cutting ceremony, but you can walk underneath that printer and we can print some really big things there at large scale. Okay, so that's all about RCAM. What can you do today, right? So I borrowed some of these slides. They're publicly available from the climate, I think it's the Climate Reality Project. And the name of that film was, you probably remember it from 2012, was The Inconvenient Truth, and then there's a sequel to that. And it's still good to watch, although it's 4 years old now, 3 years old. But a lot of those things are unfortunately coming true. But these are some of the things you can do, right? So you can use your voices, you can use your votes, you can make choices. I can tell you CEC does listen. They absolutely listen. They have briefings on offshore wind and so your voice matters there, I can tell you that. And then, of course, to end with this, it really does matter. We can do this. We are doing this. But it's still a long road. So with that, thank you. Thank you, everyone. You want to... Oh, right. Yeah, so we have, questions, of course. Yeah, I saw her hand first. I'll come to you next. Yeah. Here. Maybe do this.
How do you balance the need to use both the surface and the depth as well as sand dredging of the ocean for your projects with the importance of ocean biodiversity and particularly like surface level photosynthesis for carbon capture and storage?
So we didn't show you all of our ideas. We won't be doing sand dredging. And incidentally, that sand dredging it was intended to come from Humboldt Bay, where they have to dredge the port. And then they take that sand and they build giant sand dunes in the ocean. And we were thinking, we can use that sand, fill our anchors, and then more offshore wind turbines. So we have anchor designs that are specifically, we have a number of criteria: cost, how much they resist, what is their environmental impact. And we have some very low environmental impact anchors that help mitigate and minimize environmental problems. So.
I was just wondering the weight capacity of your anchors.
Yeah, do you want to know the weight of the anchors or how much they hold? So, yes, so in our lightest designs, our most efficient designs, the anchors, I think we're looking in about, let's say 50 to 100 tons is the mass of the anchor. Let's say 100 tons. But that anchor has to hold 1,000 tons. So the anchor has to hold 10 times, yeah, I did that right, 10 times the mass that you're using. So it's big stuff. And the anchors are twice the height of the ceiling in some of the concepts. These are anchors not like you see on that boat. They have to hold so much more capacity. The wind turbines have diameters of 250 meters. Now, 250 meters, I don't know, I'll have to walk this off, but I suspect that this building is 150 meters long, maybe. So it's giant stuff. So,
How do you get the electricity from 5 miles out to land?
so they use subsea cables, and there's been a lot of offshore wind development in Europe, and we're benefiting from that. So it's big copper protected, armor-shielded cables that go from the wind plant to the shore. And one of the reasons they pick Morro Bay is it's quite close to the nuclear plant there, and so there's infrastructure. You also need that infrastructure to then transmit the electricity to different areas. And that's also one of the reasons why we're interested in these water batteries, so that, because the wind only blows about 50% of the time. They only use those cables 50% of the time. If we connect our storage, our energy storage devices to that, we can increase the amount that that cable is used. They're expensive. It uses a lot of copper. One more. And I'm happy to answer questions. Just stop by our demo.
Hi there. So my question is education-based. How are you going to promote and educate the general public so that this is a normal thing? Because when you explain it, it was quite clear and it wasn't difficult for me to understand. But how are you going to get that across?
Are you a teacher? Great. So one of my favorite sayings is teach the teachers. And that's one of the things that they, National Renewable Energy Lab does a lot of great things. I owe them a ton of debt. But one of the things that they did is they have educational training programs, and that's where I learned the phrase teach the teachers. So yesterday we had, unfortunately I wasn't here, but I think it was 40 teachers here, and okay, raise your hand if you're a teacher. Now, let's have a round of applause. Because I certainly wouldn't be here without teachers. I was blessed with excellent teachers, and so we owe them a debt of gratitude, and we also rely on them because I didn't mention the challenge of workforce, right? We need more people, right? We need educated people, most importantly. We need all sorts of people, but right now, we need educated people to help us develop our designs and do the testing and those sorts of things. So,
give them a great big round of applause. Thank you, RCAM.